All right, we're now going to talk about what are called logarithmic functions. These functions always cause students a little bit of trouble, and it's mostly because of the notation that we use. It's nothing that we've seen in the past. So in order to motivate the whole idea behind a logarithmic function, let me start off with a function that you're more familiar with. That's an exponential function. So this is a specific exponential function, f of x equals 2 to the x. Now what I'm going to do is I'm going to try and find the inverse of this function. So remember, if we have a function, let's say, that starts off with some number we're going to plug in, let's say we plugged in the number 1 here. If it were to go through this function f, it would become 2 to the first power, which is 2. And what we're trying to find here is the function, the inverse, that would take 2 as an input and take it back to 1. Well, we've seen that we have a set of steps to find inverse functions. The first thing that you would do is you would replace the f of x with y. Then you'd switch your x and y variable, and now you try and solve for y. Now the problem here is to solve for y is stuck up in the exponent, right? And therefore we have no easy way of getting the y out of the exponent. There's no algebraic technique that we can use to get the y out of the exponent. So this is where the new notation comes into play. Think about what this is saying. It's saying that we're trying to figure out, right, x will be equal to whatever 2 is raised to here. So if you raise 2 to some power y, right, then that will give us x. So we're going to have this new notation. Here's the way we're going to write it. We're going to say log. Then we're going to put 2 down here as a subscript. And then we're going to put x equals y. Okay, now what does this mean? This means that 2 raised to some power y is equal to x. I like to look at it like a little loop. 2 raised to this power, okay, 2 raised to that power is equal to x. So you can see here it's kind of like, it's another way of writing this. 2 raised to this power y is equal to x. But notice that if you write it this way, you have your y by itself. Now this is called a logarithm, and the way that we would read that, or the way that you would say that, is log base 2 of x equals y. Okay? Log base 2 of x equals y. Now, if we do this and then we replace the y with the inverse, we've come up with the inverse function. It's f inverse of x equals log base 2 of x. See, we replace the y with f inverse, and the other side is just log base 2 of x. So this is a new function. We call it a logarithmic function, which has base 2. And it happens to be the inverse of this function. Now let's see how this would all work. If we were to take our original function 2 to the x, if we were to graph it, right, we would have something that looks like this. At 1 we'd be at 2, at 2 we'd be at 4, and we could plot this thing. We know that this is the way the exponential function would look. And the inverse function should be basically taking this and reflecting it over the identity line, which again is something we've looked at with inverses. Or you could take all the ordered pairs and switch them. So like this ordered pair is the ordered pair 0, 1. The next ordered pair is the ordered pair 1, 2. The next one is 2, 4. So now to find the inverse, you switch the order. So 1, 0, 2, 1, and 4, 2. Now if you plot these points, here's 1, 0, 2, 1 is up here, and 4, 2 is up here. Also, we could take some of the points over here, and you would see that what would happen is that this would look like this. Okay? So this is the inverse function. This is the original function. You can see that it's a reflection. You can see that the original function had a horizontal asymptote of the x-axis. Now the inverse function is going to have a vertical asymptote of the y-axis. Okay, see how that works? But the main thing, and the thing I want you to understand here, is that this, okay, This is a new notation, and we call these logarithmic functions. Now what I'm going to do in the next video is I'm going to work with this new notation just so I make sure that you really understand what this is asking.